right, so we're thinking about the limits as these are going to positive infinity or negative infinity. Talking about our x values getting closer and closer to positive infinity or negative infinity for a rational function. Now, the problem here we have to be careful with is we're not just substituting in a value, we're substituting in infinity. So we're talking about these values, like in this first one, getting very, 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 very large. All right? So when we are putting in these very, very large numbers, think about where we're placing them in. We're placing them in for the x's. And so as we're putting in like 10,000, 10 million, 10 billion, this plus 5 becomes very insignificant. Because we're multiplying that by 4, that is huge, and then plus 5, it's a very, very weak addition to this. Whatever that is times 8, that's some gigantic number. Minus 3 doesn't really affect it very much. So we can really just look at this 4x over 8x. Really, this is just so insignificant as our value for x gets so close to infinity. And 4x over 8x, we know we could cancel out the x's, and this reduces to give us a half. As x goes to positive infinity, the limit is a half. It's going to get closer and closer to a half. Let's look at this next one. As x is going to a negative infinity this time. So when we're thinking about this, x going to negative infinity, again, the value we're putting in for x is a very powerfully large number. Even though it's small, it's getting smaller and smaller and smaller. We're talking about it getting infinitely smaller, which is again a very powerful thing. When we square that, when we square negative 10 trillion, well, that's huge. And then we multiply it by 6. Whatever we subtract, well, this whole thing being squared is a lot more, like, I'm thinking of it as it's like powerful. It's a lot. It's going to be growing at a much faster rate than this x. Whatever that is. You know, if we put in 10 trillion, we square it, then we just subtract away 10 trillion. Well, whatever, we have 10 trillion squared over here. This is huge, and as we just keep putting in bigger and bigger numbers, even though it's negative, it's still being squared, and things are getting very, very large. So this becomes kind of insignificant in the scheme of things because we're squaring it over here. Very similar down here, we're cubing it, and then plus 1, that's not much going on there. So once again, we can kind of look at it as just these leading terms. We kind of ignore that stuff and we can look at these leading terms, and if we simplify this, this would be 2 over x. This is really what we can simplify it down and look at. And as x is approaching a negative infinity, as we are talking about, yes, it's negative, but we're talking about a negative number in the denominator that is really, really, really large. I mean, think about 2 over some really, really large number. Whatever you want that really, really large number to be, think about that. 2 divided by some really, really large number. You plug it in your calculator, and your calculator is basically going to say 0. The larger number we're dividing by, the closer this is going to get to 0. Even though it's negative, it doesn't matter. It's going to be getting closer and closer to 0. This limit right here, as x is approaching a negative infinity, is 0. Last one. Once again, you kind of know my spiel here. As x is approaching a positive infinity, well, positive infinity to the 4th power, that is huge. Well, there's nothing else in the numerator, but look in the denominator. X cubed. As we're cubing that number that is so large, this 2x becomes pretty insignificant. Oh yeah, and then we're adding 2 times x. Well, we just cubed it over here. That's huge. That's growing at such a large rate. And then over here, it's pretty insignificant. So we're really looking at 5x to the 4th over 9x cubed. That's the significant pieces of this function when we're talking about x going to infinity. which this does simplify down to be 5x over 9. And as we are talking about x going to infinity, as this numerator is getting larger and larger and larger and larger, well, divided by 9 becomes pretty insignificant. We're still going to be able to go to infinity. This is linear. This is going to a positive infinity in the y's as the x's approach positive infinity. Our limit here would be a positive infinity. That's what it's going towards.